Wall-mounted motion sensors with integral/B switching provisions do exist. These sensors generally feature two sets of relay contacts, labeled A and B, which can be controlled independently by the motion sensor. This independence enables the sensor to manage two distinct electrical loads, such as lighting and ventilation systems. A typical use case involves the sensor activating lights upon entry into a room and deactivating them upon departure. The same principle can be applied to ventilation, where a fan is activated upon entry and deactivated upon exit. The A/B switching capability offers several advantages in various applications. Firstly, it allows a single sensor to manage two separate loads. Secondly, it introduces redundancy, providing a backup in case one of the loads malfunctions. Thirdly, it enables the creation of varied lighting or ventilation scenarios based on room occupancy. Consider these specific applications of wall-mounted motion sensors with integral/B switching. In a bathroom setting, the sensor can activate lights upon entry and deactivate them upon exit. The A/B switching feature can then control the bathroom fan, activating it upon entry and deactivating it upon exit. In a kitchen environment, the sensor can manage the lights, activating them upon entry and deactivating them upon exit. The A/B switching can then govern the kitchen exhaust fan, activating it when cooking begins and deactivating it when cooking ends. In a living room context, the sensor can control the lights, activating them upon entry and deactivating them upon exit. The A/B switching can then manage a fireplace, activating it upon entry and deactivating it upon exit. Wall-mounted motion sensors with integral/B switching provisions offer a flexible and economical solution for managing lighting and ventilation across diverse applications. They provide a centralized control mechanism, optimizing energy consumption and enhancing convenience. The operation of these A/B switching motion sensors hinges on the use of relays. A relay is essentially an electrically operated switch. The motion sensor, upon detecting movement, sends a signal to the relay, which then either opens or closes an electrical circuit. In the context of A/B switching, there are two independent relays, allowing the sensor to control two distinct circuits. The settings of the motion sensor dictate how these relays respond to detected motion. For instance, the sensor might be programmed to activate relay when motion is detected and deactivate it after a predetermined period of inactivity. Simultaneously, relay B could be programmed to activate only under specific conditions, such as when the ambient light level is below a certain threshold. This level of programmability allows for precise control over the connected loads. Furthermore, these sensors often incorporate adjustable sensitivity settings. Sensitivity refers to the sensor's ability to detect movement. A higher sensitivity setting means the sensor will detect even slight movements, while a low sensitivity setting requires more substantial movement to trigger the sensor. This adjustment is crucial to prevent false triggers, such as those caused by pets or drafts. Time delay is another critical parameter in these sensors. The time delay determines how long the sensor remains active after motion is no longer detected. A longer time delay ensures that the lights or ventilation continue to operate for a reasonable period, even if the room is only briefly occupied. A shorter time delay conserves energy by deactivating the loads more quickly when the room is unoccupied. The installation of these sensors typically involves connecting them to the electrical wiring of the building. This usually requires a neutral wire, a line wire, and a load wire for each of the A and B circuits. It is essential to consult the manufacturer's instructions and adhere to local electrical codes during installation to ensure safety and proper operation. From an energy efficiency standpoint, A/B switching motion sensors offer significant benefits. By automatically turning off lights and ventilation when a room is unoccupied, they reduce energy waste and lower electricity bills. This is particularly advantageous in commercial buildings, where lights and ventilation often remain on even when no one is present. Moreover, these sensors can contribute to a more comfortable and convenient environment. Users no longer need to manually turn lights or ventilation on and off, as the sensor automatically manages these functions. This is especially helpful in areas where hands-free operation is desirable, such as bathrooms or kitchens. The cost of these sensors can vary depending on the features and specifications. However, the energy savings and convenience they provide often outweigh the initial investment. Furthermore, many utility companies offer rebates or incentives for installing energy-efficient lighting controls, which can further reduce the cost of these sensors. In terms of future trends, the integration of these sensors with smart home systems is becoming increasingly common. This allows users to control and monitor the sensors remotely, adjust settings, and receive notifications. For example, a user could receive a notification on their smartphone if the sensor detects motion in their home while they are away. The evolution of wireless technology is also impacting these sensors. Wireless motion sensors eliminate the need for extensive wiring, making installation easier and more flexible. These sensors typically communicate with a central hub or gateway, which then controls the connected loads. Furthermore, advancements in sensor technology are leading to more accurate and reliable motion detection. For example, some sensors now use infrared technology to detect heat signatures, which reduces the likelihood of false triggers. In summary, wall-mounted motion sensors with integral A/B switching provisions provide a versatile and energy-efficient solution for controlling lighting and ventilation in a variety of applications. Their ability to manage two separate loads, combined with adjustable settings and integration with smart home systems, makes them a valuable tool for optimizing energy consumption and enhancing convenience. When selecting a motion sensor with A/B switching, consider the following factors. Firstly, assess the specific needs of the application. Determine the types of loads that need to be controlled and the desired operating parameters. Secondly, evaluate the sensor's specifications, including its range, sensitivity, and time delay settings. Thirdly, consider the sensor's compatibility with existing electrical systems and smart home devices. Fourthly, check for certifications and approvals from recognized testing laboratories such as Underwriters Laboratories or Canadian Standards Association to ensure safety and performance. Finally, read reviews and compare prices from different manufacturers to find the best value for your needs. Properly installed and configured, these sensors can provide years of reliable and efficient operation. They represent a smart investment for both residential and commercial properties seeking to reduce energy consumption and improve occupant comfort. Beyond the basic functionality, some A/B switching motion sensors offer advanced features. One such feature is daylight harvesting, where the sensor automatically adjusts the lighting levels based on the amount of natural light available. This further reduces energy consumption by dimming the lights when sufficient daylight is present. Another advanced feature is occupancy counting, where the sensor tracks the number of people in a room and adjusts the lighting and ventilation accordingly. This is particularly useful in large spaces such as conference rooms or auditoriums. Furthermore, some sensors offer remote control capabilities, allowing users to adjust settings and override the automatic functions from a smartphone or tablet. This provides greater flexibility and control over the lighting and ventilation systems. When designing a lighting or ventilation system with A/B switching motion sensors, consider the placement of the sensors carefully. The sensors should be positioned in a location where they have a clear view of the area they are intended to monitor. Avoid placing the sensors near obstructions such as furniture or plants that could block their view. Also, consider the ambient temperature and humidity levels, as extreme conditions can affect the sensor's performance. In addition, it's crucial to consider the load capacity of the relays in the motion sensor. Each relay has a maximum current and voltage rating that must not be exceeded. Exceeding the load capacity can damage the relay and potentially create a safety hazard. Always check the manufacturer's specifications to ensure that the relays are suitable for the intended loads. From a maintenance perspective, A/B switching motion sensors typically require minimal upkeep. Periodically clean the sensor lens with a soft cloth to remove any dust or debris that could impair its performance. Also, check the wiring connections to ensure that they are secure and free from corrosion. If the sensor malfunctions, consult the manufacturer's instructions for troubleshooting tips. In some cases, it may be necessary to replace the sensor. The lifespan of these sensors can vary depending on the quality of the components and the operating conditions. However, with proper care and maintenance, they can typically last for many years. In conclusion, A/B switching motion sensors offer a wide range of benefits for controlling lighting and ventilation in a variety of applications. Their ability to manage two separate loads, combined with advanced features and integration with smart home systems, makes them a valuable tool for optimizing energy consumption, enhancing convenience, and improving occupant comfort. By carefully considering the factors discussed above, you can select and install the right sensor for your needs and enjoy years of reliable and efficient operation. These devices are becoming increasingly prevalent in modern buildings, reflecting a growing awareness of the importance of energy efficiency in sustainable design. The integration of these sensors with building management systems allows for centralized control and monitoring of lighting and ventilation across an entire facility. This enables facility managers to optimize energy consumption, identify potential problems, and improve overall building performance. Moreover, the data collected by these sensors can be used to analyze occupancy patterns and identify areas where energy savings can be further improved. For example, if the data shows that a particular area is rarely occupied, the lighting and ventilation can be reduced or turned off completely during those times. The use of A/B switching motion sensors is also aligned with various green building standards, such as leadership in energy and environmental design. These standards encourage the use of energy-efficient technologies and practices to reduce the environmental impact of buildings. By incorporating these sensors into building design, it can contribute to achieving a higher level of sustainability and reducing its carbon footprint. In addition to the environmental benefits, A/B switching motion sensors can also improve the safety and security of a building. By automatically turning on lights when someone enters a room, they can deter intruders and reduce the risk of accidents. Furthermore, some sensors can be integrated with security systems to trigger alarms or send notifications if motion is detected in unauthorized areas. The application of these sensors is not limited to indoor environments. They can also be used outdoors to control lighting in parking lots, walkways, and other areas. In these applications, it is important to select sensors that are designed for outdoor use and can withstand harsh weather conditions. Outdoor sensors typically have a higher degree of protection against moisture, dust, and extreme temperatures. They may also have additional features, such as vandal-resistant housings and tamper-proof screws. When using A/B switching motion sensors outdoors, consider the potential impact on wildlife. Avoid placing the sensors in areas where they could disturb nocturnal animals or interfere with their natural behaviors. Also, use appropriate lighting fixtures that minimize light pollution and direct the light downwards to reduce glare. The advancement of technology is continually driving innovation in the field of motion sensors. New types of sensors are being developed that are more accurate, reliable, and energy efficient. For example, some sensors now use microwave technology to detect motion. Microwave sensors are less susceptible to false triggers than traditional infrared sensors and can detect motion through walls and other obstacles. Other sensors use ultrasonic technology to measure the distance to objects. Ultrasonic sensors can be used to create detailed maps of the environment and track the movement of people and objects in real time. The integration of these advanced sensor technologies with A/B switching capabilities will further enhance the performance and versatility of motion-activated lighting and ventilation systems. As the demand for energy-efficient and sustainable buildings continues to grow, A/B switching motion sensors will play an increasingly important role in creating a more comfortable, convenient, and environmentally responsible built environment. These devices represent a simple yet effective way to reduce energy consumption, improve occupant comfort, and enhance the overall performance of buildings. Their versatility and adaptability make them a valuable tool for architects, engineers, and building owners seeking to create a more sustainable future. The ongoing development of new sensor technologies and integration with smart home systems will further expand the capabilities and applications of A/B switching motion sensors in the years to come.